In object-oriented programming, such as Java, a class is a blueprint for creating objects. A class defines a data type by bundling data and methods that operate on the data into one single unit. You can think of this class as a blueprint having variables to define these data attributes or fields and methods to define its behaviors. There's also a special type of methods. We call them constructors. You can think of these as the entry point for these classes to become objects at runtime. Classes are static. Objects are more dynamic in a sense, wherein the blueprint, you see properties of this object and also the behaviors of this object. You also have constructor. This is very similar to a method or function that allows you to move this static class into an object at runtime. In this video, we'll look at the anatomy of a class. We'll also show you the UML, which is Unified Modeling Language, a standardized visual modeling language used to design and document software systems. Specifically, we'll look at class diagram to aid your understanding of the class. As we move forward, let's look at the anatomy. This is a general class. Its name is Circle. There's class scope using a pair of curly braces. Then you have a whole bunch of data fields. There's only one here, double radius 1.0. This is a circle class that has radius and methods or behaviors that allows you to construct the mechanism to get its area. From your math class, we know the area of a circle is radius square times pi. These two method-looking functions are what we call constructors. Notice that there is no return type associated with these constructors. These constructors are your entry point to creating its circle object. You can have multiple constructors, and notice every single constructor is different in terms of their parameters list. For example, the very first constructor has no parameter at all. This is what we call default constructor. We'll get into this a little bit more later. You also have user-defined constructor that has a custom parameters list involving one parameters in this case. Together, we call this data field property. And this method will be the behavior that define the functionality or capability of this circle class. Every class as a blueprint would have a property and behavior associated with it. In addition, constructors. Sometimes the constructors may not be necessary if you're dealing with default constructor that does nothing. As in this case, there is nothing inside this default constructor. You don't even need to include it. In fact, Java will supply this default constructors to every single blueprint at compile time. This means if there's nothing in a default constructor that you wish to define, you can just leave it. You don't need to include it. These user-defined constructors are more important. The fact that you have definitions in it means they may need to be used. You'll make sure your circle class has it. Let's look at this class's Unified Modeling Language diagram. This is UML class diagram. As stated, UML is a standardized visual modeling language used to design and document software systems. What you're looking at here is a class diagram. It provides a set of graphical notations for specifying, constructing, and documenting the artifacts of your class. On the very top, you have class name. In the middle portion, we have properties or fields. On the very bottom, you have a list of behaviors. These are methods, including constructors. This is just for one circle class. You could have other classes by different names. You can simply use this UML or Unified Modeling Language to draw them out. Later on, when your software system becomes more complicated, these classes might relate to other classes, and you would use class diagram to map out their relative relationship to each other. For your info, UML provides a variety of diagram types. This is just one of them. There's also use case diagrams, like ones showing the interactions between users or actors and the system to achieve specific goals or functionalities. There's also sequence diagrams. that depict the interactions between objects over time, showing the order of messages exchanged between them, activity diagrams illustrating the flow of activities, state diagram that model the behavior of objects or systems. So this UML becomes more complex. But the use of this modeling abstractions help developers in general to understand the composition of their software at design time. That is, before they implement the software. On the bottom here, you see the object representation. So these objects are constructed by way of either this default constructor or this user-defined constructor at runtime. You have three objects, circle 1, circle 2, circle 3, and noted the colon separating the class. You also have the runtime value of radius, 1.0, 25 to 125. Now that we have this holistic view of this circle class, let's look at how we define classes and creating objects from them. This is another example of a class blueprint for building a television. This television class has a whole bunch of fields or properties like the channel number, TV channel, volume levels, and whether this TV is on and off. This on and off property is also the state of your TV. So in one state, the TV could be off. In another state, this TV could be on. Now let's look at these behaviors. You'll notice this plus sign. These plus signs indicate that they are publicly available, meaning if you're a user, and this user does not have to be an actual person, it could simply be another object. This object is external to this TV object. And because this TV object, once constructed at runtime, it has these publicly available behaviors that could be used or invoked by an external object because they are public. If you were to turn this into private, then other objects won't be able to use it. This is slightly more advanced. We'll look at this when we study OOP in later videos. You don't have to memorize this, but you will notice the way we defined the behavior in this class diagram is we would specify its return type at the end of the semicolon. So this turn on method returns a void. This turn off method returns a void. So it's with set channel, set volume, channel up and down, volumes up and down. Each of these behaviors has a specific purpose, like turning on the TV, turning off the TV, so on and so forth. You will see the parameters list, their parameter name, and the type associated with it in a similar fashion with a colon in between them. We also see a TV default constructor. A default constructor is very easily discerned because it carries the same name as your class. It does not have any return type here, and it has no parameters list. This is the default constructor for this TV class. If you do not specify this default constructor, your compiler will. This should complete the anatomy of a class, giving you a holistic view of a class blueprint. We use UML to represent its inner properties and behaviors to convey clarity in a complex system design.